What's going on? Today we're going to talk about Slingshot. So Slingshot is a room that is part of SOC level 2, and it is a wrap up of everything that you have learned about the Elastic Stack. So before attempting this challenge, I recommend you guys, if you haven't done these rooms, I recommend you guys to go back to these rooms and try to answer the questions, learn the concepts. And for the walkthroughs, you can check out the playlist here, which contains 4 videos about Elastic Stack, and this playlist contains the videos to solve these rooms. Okay, now after you have done these rooms, or having done and completed these rooms, you can now attempt to do Slingshot challenge. So Slingshot is a challenge where you put all the knowledge you have gained about the Elastic Stack into practice. In the Slingshot, the scenario is actually a cyber incident response to a database that has been hacked. So the scenario here goes like this. Slingway, a leading toy company, has recently noticed suspicious activity on its e-commerce web server and potential modifications to its database. Okay, so here the website, the database of the website has been hacked, and there were some modifications on this database. To investigate the suspicious activity, they have hired you as a SOC analyst to look into the web server logs and uncover instances of malicious activity. So basically, the attack just happened. They have the logs, namely the web server logs, and the administrators have actually uploaded the logs into the Elastic Stack. So as a SOC analyst, you will directly deep dive into the logs and analyze what just happened. So what's we're gonna do? We're gonna just deploy the instance, copy the IP address, the username, and the password, and that's what we get. So don't forget to adjust the date to start on July 6, 2023. Once you do that, you will get 3028 hits. These are the web server logs, namely the Apache web server. On the left side, we have the fields that have been parsed by the Elastic Stack. Now, what are we going to do? We want to build the chain of events, starting from the very first attacker attempts, represented by the scanning attempts that the attacker had completed against the target, and leading all the way up to the credential harvesting. So we believe that the attacker first attempted to scan the target, okay, because every attack starts with the scanning. So when you investigate a cyber incident response or a cyber incident like this one, you may want to refer to the MITRE framework or the available frameworks that will guide you through the stages. For example, the cyber kill chain is a good example, perfect example to follow through when you are investigating a cyber incident. A cyber kill chain starts with a reconnaissance. So first we want to find out what the attacker did. Okay, what the scanning software the attacker used. So here we have the current view. We want to adjust the display of the fields. On the left side, we have the fields. So we want to adjust the display here. What we're gonna do, we're gonna add some fields to the view. So we're gonna highlight the view you want and click on the plus icon, add field as a column. So we want to add the URL. We want to see the requested URL. We also want to take a look at the response status. The user agent. Why the user agent? Because the user agent will allow us to check what is the attacker's fingerprint, meaning what software they use to perform the action, whether it is scanning, directory enumeration, or even credential brute force. All will be in the user agent. So we're going to add this here. So now we have the these, we can also need the IP address. This is the source IP address with respect to the web server, meaning the web server IP address. We don't need it. We want the IP address of the attacker. So we're looking for a remote IP address, transaction remote underscore address. So we added all this. Now we want to adjust this to a comfortable display. So we're gonna click on display options, and we select single to have a compact view of the columns. Okay, now this looks nice. We have the timestamp, the URL requested, the status, the web server returned, and the user agent and the IP address. We can sort this as well, ascending or descending order. We want to start with an ascending order, starting from the very early web entry log, leading all the way to the last action. So we're gonna click on this, and we sort this all to new in an ascending order. Okay. All right, so what we want to do now, we want to find out, first thing first, the attacker's IP address. So since these represent web server logs, there might be more than, or there is definitely more than one IP address, several IP addresses interacting with the web server. It's an e-commerce website at the end. So we want to see, since the interval we have represents the incident or the cyber incident. So we want to look at the requests performed by the most requests performed by which IP address. So you can click on this field and we can see a breakdown of the top values, starting with the IP address with the most requests. This reminds me with Splunk. In Splunk, it's the same way. When you click on a field, you get statistical information about the top requesting values. So we have here the IP address 10.02.15. It occupies, or it takes 84% share of the traffic, which means this is probably the IP address of the attacker. After highlighting the IP address of the attacker, we now know the IP address of the attacker. We want now to find out what scanner they used, along with the URLs requested. We can use the user agent to accomplish this. So we see the attacker used different user agents depending on the type of request or the operation they are actually undertaking. So we see here we have a user agent that matches Nmap scripting engine, which means the attacker has actually used Nmap to do some Nmap scans. If you scroll all the way down, we can also check out these. We can also find other user agents such as the GoBuster, which is a popular tool to perform directory enumeration and brute force. So we have more than one user agent that indicate the attacker's attempts throughout the cyber kill chain. So we have Nmap for the scanning and reconnaissance. We have GoBuster for the enumeration and so on. So going back to the challenge, now the first question is asking the attacker's IP address. We already answered this. What was the first scanner that the attacker ran against the web server? So see here in the question, there is a hint which is revolves around the first word. So here, the first scanner, it means you have to sort the events from old to new, as we did earlier. If you do that, you are just a couple clicks away from finding out the user agent, which highlights Nmap scripting engine. What was the user agent of the directory enumeration tool that the attacker used on the web server? Again, if we scroll down more, we can find out that it is GoBuster. Now let's say that you have more than 3,000 events. Let's say you have 20,000 events in a short time span. So what are you going to do? Are you going to just look for the user agent by just scrolling through? It is not a practical way. So what we're gonna do, we're gonna use the KQL. So in KQL we use queries to look for the events and to extract the insights. In here we know that the footprint of a scanning software lies in the user agent. So we can write request headers user, and we take advantage of the autocomplete feature in Elastic Stack. So we click on this, and with a colon here we can actually specify the value. Now again, with the autocomplete we get all the possible user agents extracted from the events. We see we have Hydra, we have GoBuster, and we have Nmap. These represent the software or the tools the attacker used throughout the attack. So we have Hydra for credential brute force, GoBuster for directory enumeration, and Nmap scripting engine for the scanning. So now we already have a couple of questions already answered. So GoBuster for the enumeration. In total, how many requested resources on the web server did the attacker fail to find? So he was looking to find out how many requests the attacker conducted against the web server where the response code was 404, none found or not found. So we're gonna use the response status. So response status and use 404. We update and we will get the list of all the log entries where there was 404. So in total they are 1,867. What is the flag under the interesting directory the attacker found? So here we're gonna just modify this a little bit and use 200. This will give me a list of all of the log entries that represent the pages that have been actually crawled and found by the attacker. We want to find the flag. So probably here we want to add another query to the KQL here. The query here will be about the user agent. Since we know that the attacker actually used directory enumeration to find enumerated directories, we're going to assume that the flag was found this way. So we're going to use and here request let's look for the user agent, request headers, user agent. We're going to select GoBuster and update. So now here we're looking to find actually the pages that the attacker managed to discover using GoBuster. So we see all of these pages have been discovered by GoBuster, and we see this one /backups/flag. We can click on this button to expand this, and we can see the complete flag. What login page did the attacker discover using the directory enumeration tool? Okay, so we are still with GoBuster, but we're going to modify the query. So instead of looking for the response status 200 or the discovered pages, we're going to add another AND statement, http://URL. We want to find clues about the login page the attacker found. So it is a login page. So probably it contains the word login. We're going to use wildcards to match against all the pages that contain the login word. So what we can do, we can use /wildcard login wildcard. So here we're looking to match all the pages that contain the word login, and we don't care what comes after the word login and what comes before the word login. Update. You see in total we have 6 hits. We're looking for a page, not a directory. So we have 2 pages. We have login PHP and admin-login PHP. Both returned, or one returned 404, not found, and one returned 401. So probably, not probably actually, definitely the login page or the correct one is admin-login, judging by the response status. What was the user agent of the brute force tool that the attacker used on the admin panel? So now we know the admin panel, admin-login. And let's assume now we don't know the user agent. We know it is Hydra. Earlier we found this, but let's now answer the question differently. We want to find the tool the attacker used to brute force or to perform the credential brute force. So we're going to use the login page as the criteria here. So we're gonna remove all this. The URL will be admin-login.php. Let's see all the hits on this page. Seeing all the hits on this page will allow us to figure out all the user agents used. So we have regular user agent and we have Hydra. So when we see Hydra, we automatically assume that yes, that was a credential brute force attack. So it is Hydra. What username password combination did the attacker use to gain access to the admin page? Okay, so we're looking to find out the credentials. Let's go back. Here, okay, so admin-login. So what we're going to do here, we can sift through all of these and extract the credentials by looking into them one by one, but this is not practical. We're gonna need a more practical method. So to do that, we're going to use a response status. So because the attacker has managed to discover the credentials, the response status must be 200. We use and response status 200. And we have only 2 hits. We can take a look at the one that highlights Hydra as the user agent. Scrolling down, we see request headers authorization. This is the classic authorization that asks for username and password. If we take this and go to Cyber Chef from base 64, and we have the username and password. What flag was included in the file the attacker uploaded from the admin directory? So after the attacker managed to log into the administration panel, what they want to do now, they want to upload a reverse shell. So here we want to discover first the upload directory in the web server. So to do that, we're going to go back, and here we're going to cancel this. We're assuming that the upload directory is under admin directory. So we're going to use a wildcard here and wildcard here. We're going to get a lot of hits. Okay. Alright, so how to find the correct upload directory? To find the correct upload directory, we're going to have to go back a little bit. So here we know that the attacker managed to find the username and password using Hydra. What they want to do now, they're going to take the username and password and manually log in to the administration panel, meaning the user agent of the attacker will be a regular user agent. It's not going to be GoBuster, it's not going to be Hydra, it's not going to be Nmap. So what we're going to do, we're going to add another filter here and request headers user agent. We're going to select the Linux user agent because it represents the web browser the attacker used. You can update and see how many hits. So we have 164 hits, and now we get some clues. Look at this, /admin/upload.php, and it is 200. So this is the upload directory, right? Now we want to find what the attacker uploaded to the web server. So we're going to modify the URL filter here. The URL filter is going to be now modified and will include /admin/upload.php. Let's see now. So we have one request. Let's take a look at this. Okay. Looks like we're gonna have to modify this again. So we're gonna use wildcard after the PHP. Why? Because if the attacker uploaded a file to the web server, there will be request parameters, right? The request parameters come after the file name that handles the upload process. So that's why I use a wildcard here and update. Now we have two. So the other one here, let's take a look at this. Probably it highlights an upload process with a file. Scrolling down, we have a request body now. Clicking on the arrow here will expand the request body, and we see that, let's see here. We see that the attacker uploaded a file named Easy Simple Webshell. That's the webshell the attacker uploaded after they discovered the credentials. Scrolling down, we can see also the flag requested in the question. So in the question, they ask you for the flag, but in fact, they want you to actually find the name of the webshell. What was the first command the attacker ran on the webshell? Now things start to unveil, right? We now know what's going on, what happened, how the attacker got in. Now I want just to find out what the attacker did after they gained access. So now we can copy the name of the webshell and use it in the filter. I'm going to return all the logs that contain the webshell. So we see in total we have 6 hits. Probably these 6 hits, apart from the first one, which was the upload process, they represent the commands the attacker executed through this webshell. All is gonna be in the request parameters. Let's take a look at the first one. Okay, the first one is, let's expand the message section. So this is the webshell. This is the upload. This is the upload. Let's take a look at the other one. And now we can see the request parameter CMD as I'm highlighting, and the first command was who am I. If you are curious, you can also take a look at the other entries to find the other commands. So the next command was pwd, print working directory. And then they used ls to extract the contents of the working directory. And the other one, which in C, they're trying to figure out the path of the netcat tool. Probably they want to create a listener, or they want to connect to their attacker machine and have another reversal. Right, so now we answered the question. It is who am I. What file location on the web server did the attacker extract database credentials from using LFI? This question is a little bit convoluted because you don't know where to look. Probably here we want to find out the actual file name that stores the database credentials. So when the attacker gained access to the website, they now control the database. they want to look for plain text credentials and hard-coded credentials, which means they will look for configuration files that may contain these credentials. So to find out the file name, you want to use the URL. I'm going to go back here and use the URL field. So what are we going to put here? We know that the configuration file for the database will contain the word DB, because that's how it is. So we're going to use the word DB between two wildcards. Okay, we have around 26 hits. If you want to narrow this further, you can use and request dot status. You can use 200. Oh, okay, fine. Scrolling back, let's go use only this. 26 hits. We have actually 200, request status 200. I don't know why it didn't work. Let's attempt one more time. Response status, it's not request. Okay, we have 14 hits. So the very first, let's take a look at the very first one. So it is a request to this path, admin settings page. We see we have here traversal to etc phpMyAdmin config. This is the actual configuration file that stores the credentials. As you can see, the attacker used directory traversal beside local file inclusion to access the file. What directory did the attacker use to access the database manager? We already answered this. It's phpMyAdmin. What was the name of the database that the attacker exported? You see, the author has highlighted exported. In every question, they are highlighting a word or two to give you a hint on how to find the answer. So you have exported highlighted. How would an attacker export a database in phpMyAdmin? They would do that. Of course, they will want to navigate to the corresponding page in phpMyAdmin, and that page's name happens to be export.php. We can assume that you don't know this, okay? Although you should know it. As a SOC analyst, you should be familiar with phpMyAdmin and other database software. But I'm trying to simplify things as much as I can. So in the request URL, I'm going to modify this and include export between two wildcards. Don't forget this. So we have a couple ones. We have export PHP, which is 404. We're going to look at the ones that return an actual page. We have phpMyAdmin/export. So if an attacker wants to extract the database from phpMyAdmin, they will head to this page. So we'll want to take a look at all the log entries here that highlight the export. Let's take a look at the first one. So we see a request to phpMyAdmin tbl_export, and DB name is highlighted here, customer_credit_cards. That's database name. What flag does the attacker insert into the database? So now they are inserting, they are modifying the database. So how are we going to find this? What is the page that the attacker has to navigate to in order to insert something into the database? Well, not all the time it can be clear, but to find the answer, we're going to exclude export from the search, and we're going to just reset the search for now to only phpMy. We're going to have first remove the wildcard, phpMyAdmin, and then wildcard. Let's first take a look at the all sorts of pages that the attacker navigated to figure out which one could be the one that actually contains the insert statement. And let's also filter for and only the returned or the actual pages that were found. Response status 200. Okay, 144. Let's see here. So up until now we have regular requests to the themes page. We're not interested in this one. Okay, switch to the second page. We have export. We now know that export is used to export a database. Navigation, now export. We have a change. Look, TBL underscore change could be used to modify a database and insert records. Also have TBL underscore replace. So let's use a filter here, /TBL, okay, to find all the TBL requests. We have 6 sets. So structure, export, change, replace, structure, export. If you look into the replace, we see here request body. It is a URL encoded value. We can use the URL decode. URL decode. Okay, let's see here. So it's a request to Ajax DB. The database is customer credit cards. And go to TBL underscore SQL. That's the file that was requested. So what happened? Let's see here. Database was specified as customer underscore credit underscore cards, and the table is specified here. And this is the SQL query. But we don't see type equal insert. After insert, we see an insert operation, but we cannot find out what was inserted. Let's go back here. So we have replace and we have change. Let's take a look at change. So in change, we don't have a request body. Okay, we want, looks like we're gonna have to look more. So structure, export, okay. So it looks like the page used to insert the request or the statement doesn't contain TBL. So we're going to go back to our regular search, the previous search. We were at the second page. Okay. So we see here import. Import page is used to import a database to the PHP admin. Let's take a look at this one. And there is a request body. Let's see here. Have a look at this value, and we're going to decode it into decode. Let's paste one more time and decode. So database was specified, table was specified here, the token, the page or the file. And we have a message. Your SQL query has been executed successfully. And we have a previous SQL query. Okay, it was insert into credit cards. That's the table to which the value was inserted. And these are the columns: card number, cardholder name, expiration date, CVV. The values inserted was 000 for the credit card number, and a value here for the holder name and zeros. So that was the flag value. It was inserted as a card holder name. So that was the answer for this question. And this wraps up this challenge. Okay, so that was it, guys. I hope you enjoyed this, and definitely I'm gonna see you later.